Hi there, you incredibly talented, amazingly tenacious honors algebra kids. So what we're going to do today is practice the skill you just barely are learning for solving a system of three equations or linear equations in three variables. So it is there are a lot of steps, let's just put it that way. It's not like the concept is too hard for you. There's just so many little components that if you don't concentrate and you make some small mistake as you go, you'll lose confidence because things will go wrong. So you're going to want some loose leaf paper today for sure. You're going to want a calculator, and you're going to want to make sure that you stay a step ahead of this mix and do one step at a time and then play it and make sure you're right, or you will really not develop the strength you need. You can do this and you'll be so proud of yourself when you do it, but it's going to take a lot of work. So here we go. Let's pick up on page 192 where the check your understanding and the practice are. So first we just get warmed up here by comparing and contrasting systems of two linear equations or linear equations in two variables with systems of three linear equations in three variables. So basically, you know, two variable systems have ordered pairs for solutions, right? Remember? And three variable systems will have ordered triples. Three variable systems have ordered triples. So they come out in X, Y, Z sets because you're working in three dimensions as solutions. So there's the contrast. Both can be solved by substitution or elimination. And if you had experience graphing planes in three dimensions, you could solve by graphing also, but we're not going to go there right now. So then for number 9, they want us to explain how we could use the first equation in this system to eliminate x from the second and third equations. So to eliminate x in the second, if we just use the first and the second, we could add first and second equations to eliminate x, because since x's are already opposites, that would eliminate x in the second equation. You would eliminate it in the first. We'd have a resulting different equation, right? But we're talking about eliminating it from this one and this one. So then we could use this first equation to eliminate x from this third equation by, if you see, we've got an x and a 2x. So we could multiply first equation by -2 and then add first and third equations to eliminate x. So the idea when you get started is you want to get rid of one variable. So we chose x here. So that would eliminate x from the third equation. Then we'd have a resulting equation from these two and a resulting equation from these two that only had y and z in them, and we could take it from there, solve it like a system of two equations in two variables. All right, so we're going to have three problems we get to practice here today. In the first one, they want us to do substitution. So definitely give your very best effort on your loose leaf to do this yourself, okay? And there's multiple ways, right? So if I was approaching these three and they wanted me to do substitution, I would probably just solve this first one for x. Okay, we need to isolate one variable. You could just as easily isolate z in this one, or you could isolate x or y in this one, right? You have to choose a starting place. I am going to choose to isolate x in this first one. So I would add 3y to the other side and subtract z. So I would end up with, I'm not going to show every single step, but you need to. You need to show how you're getting from one thing to the other. So if I isolate x in this first equation, I would get x equals, I'm adding 3y, I'm subtracting z, and I already have negative 15 over there. So here's what the variable x equals. So then I could take that and plug it in to one of the other equations to get get an equation without x in it, right? So if I plugged that into this second equation here, I would have 2 times x, and x is now this stuff here. So 2 times 3y minus z minus 15 plus y minus z equals negative 2. So I'm using this second equation here, and I'm replacing x with what I got x to be there. So if I clean this up a little, I would have 6y minus 2z minus 30 plus y minus z equals negative 2. So you can see there's just a lot of pieces to it. So if I combine like terms, 6y and y would give me 7y. Negative 2z and negative z would give me negative 3z. And if I add 30 to this other side over here to get rid of it, I would have equals 28. All right, so here I have an equation in two variables, y and z, right? So now if I take this third one and I make the same substitution for x, I'm going to put this stuff here in for x, then I'll end up with another equation with no x in it. So I would have my 3y minus z minus 15, and taking this whole equation here, I just plugged in this part, I would have plus y plus 2z equals 1. So when I combine these like terms, 3y and y gives me 4y. Negative z and 2z will give me just a z. And then if I add 15 to both sides to get rid of that, I would have equals 16. So now I have two variables and two equations, okay? And now I want to isolate another variable. So the easiest one, I've got 7y, negative 3z, 4y, and z. So this one right here is the easiest one for me to isolate. So if I subtract 4y from both sides, I'll get z equals negative 4y plus 16. So that's what z equals. We know what x equals up here, okay? So now, if we take one of these equations, let's say this one here that we created that only has y and z in it, and we make this substitution of this stuff here for z, what we'd end up with is 7y, so 7, you gotta write neatly, don't you? Minus 3, and then for z, we're making a substitution, negative 4y plus 16. You're gonna have to pause this, rewind, follow. The thing is, you just can't lose your place, right? What you're trying to do is get a variable isolated and substitute it in somewhere. Then you'll get an equation with less variables. Then take what you've got and isolate something else and substitute it in. So we're working with this one over here, right here, and we've substituted in our new z value here, negative 4y plus 16. And that's supposed to equal 28. So 7y minus 3 times z, which is this jazz, equals 28. So if we clean this up a little, we'll have 7y plus 12y minus, let's see, 30, 48 equals 28. So combining like terms, I would get 19y. I'll add 48 to both sides, right? To cancel that off. So I'll get 19y equals 76. And please pause this and do this yourself so you can be sure. And now you're going to divide both sides by 19. So you get y equals 4. Once you know what y equals, once you get one variable solved, all right, here's our solution. We don't know what x is yet. We don't know what z is yet, but we know that y is 4. And we come right back to these here. We know z is negative 4 times y plus 16. So z equals negative 4 times 4 plus 16. So z is going to equal negative 16 plus 16, which is 0. And then we'll do the same thing for x up here. So coming from this one, we know that x is 3 times y, and we know that y is 4, minus z, and we know that z is 0, and minus 15. So x equals all that stuff, right? So x equals 12 minus 0, which is nothing, minus 15. So x equals negative 3. So now we've got our final piece to the puzzle. Negative 3, 4, and 0 is the ordered triple solution to this system using substitution. Okay, now we're going to try another one and we're going to use elimination. Okay, so wiggle your fingers, shake out the cramps, wiggle your toes, blink your eyes a few times. You've got to stay super focused here. So the idea is we want to take two equations at a time and eliminate one variable, right? So we can see pretty easily that if we take the first two equations, we can eliminate x right away. So let's do that. Let's take 3x plus y minus z equals 4, and negative 3x plus 2y plus 2z, got to keep them lined up, I'm a little out of line here, equals 6. And I know I go kind of quickly, so you're going to pause and do the next step yourself every time, and then play it until you're caught up with yourself, fix any mistakes, and then pause it and do the next step. And see if you can pause more often and finish more thoroughly by yourself every time you get a chance. So let's see here. This would eliminate x, and we'd have y plus 2y would be 3y. Negative z plus 2z would just give us a z equals 10, all right? So there's one equation in two variables. Now, we will take, might as well just take the first and third, okay? First and third. We need to take a different pair, and we'll eliminate the x variable from those two. Nope, I'm changing my mind. I'm going to use these two here, second and third, instead. Because then, can you see how I can just multiply this third one by 3? And the x's would automatically cancel out. I won't have to mess with signs like I would if I used first and third. So I'm going to use second and third. So I've got negative 3x plus 2y plus 2z equals 6. And on the third one, I have x minus y plus 2z equals 8. Now you've got choices. You could have chose differently, but this is what I'm choosing. So I'm going to multiply this bottom one by 3. Okay, so I'm just going to bring this over here. So I'll have the top one will still be negative 3x plus 2y plus 2z equals 6. And now I've got 3x minus 3y plus 6z equals 24. When I distribute this 3 to the entire equation, don't forget that last side right there. Got to make sure you get the right side. Okay, so x's are gone. 2 minus 3 will give us negative y plus 8z, and we're going to get 30 here. All right, so now I've got two equations here and here in two variables, okay? So I'll stack those up, and you can probably see that if I use this one here and this one here, I could get the y's to cancel out if I multiplied this one by 3, right? So I'm going to go ahead and do that and stack it up. I would have negative 3y and 24z and equaling 90. Okay, so if I cancel out my y's there, I'll have 25z equals 100. And then I'll divide, and I'll end up with z equals 4. All right, so for my triple, I don't know x yet, don't know y yet, but I know that z is 4. Okay, so now what we'll do is I'll come back to my first two equations here, and I know what one letter is. Z is 4. So I'm going to go ahead and put 4 in for z, and then I'll just have a system in two variables. So if I bring those down here, I'll have 3x plus y minus 4 equals 4. So that would be 3x plus y equals 8, right? Okay, now I'll bring this other one right here, and I'll get negative 3x plus 2y plus 2 times 4 equals 6. So negative 3x plus 2y equals, this would be 8, right? And if I minus 8 from both sides, I'll get negative 2. So if I stack these two up, so here's my other one, with z's turned into a number, so now I only have x and y. Now if I stack these two up here, I would be able to eliminate my x. And once you get one thing eliminated over here, and you know what z is, it starts to break down and get easier and easier. So x's are gone. Now I have 3y equals 6, so y equals 2. So now I know another piece of the puzzle. Y is 2. So if z is 4 and y is 2, now I can just use any equation I want and plug those two in. So I'll just use this third one. It's pretty simple here. So if I bring that third one all the way down here, I would have x minus y, which is 2, plus, I shouldn't make that 2 look like a z, but 2 is x, plus 2, because we're taking this equation from up here, right? 2 times z, which is 4, equals 8. So I have x minus 2 plus 8 equals 8. 8, I wrote 6. So x plus 6, I probably combined those in my head, equals 8. So x equals 2. So our final solution is 2 for x, 2 for y, and 4 for z. Do you need more scratch paper? Get yourself the space to do the detail work that you need to be able to do, because you can do this. So we got one more here. Let's see if we can solve this application problem. So we've got this table of frozen yogurt sales during each hour, 1 to 2, 2 to 3, and 3 to 4. And it shows how many small, medium, and large cups are sold. And first we're supposed to write a system of equations that we could use to determine S, M, and L. Now, I am not going to use S, M, and L, because when I use S, it just gets too close to looking like a 5, and L's look too much like a 1. So I'm gonna tell myself that small is X, medium is Y, and large is Z. And then I can always change them back to those letters at the end. X is small, Y is medium, and Z is large. Now I'll fix it at the end, but I want to make sure I have variables that I can follow, because as you know, there's a lot of pieces to this. So let's see. The first equation would be 6 smalls plus 10 mediums plus 8 larges made a sale of $97.60. Then 9 smalls, 12 mediums, and 5 larges made a sale of $100.80. And lastly, 10 small, 12 medium, and 4 larges made a sale of $99.20. So hopefully coming up with the system wasn't too much trouble. Now you want to solve it. You can use any method you want to solve it. okay? I'm gonna give you my feeling on this. You can do whatever you want, okay, because it'll all work. If I go for substitution, I am going to have all kinds of fractions and decimals in my problem that are just a potential for disaster for me, okay? So I'm going to go for elimination. I'm still going to have decimals I have to deal with on that money side, but that's not as big a deal to me as trying to deal with a bunch of fractions in my, or decimals all over the place in my substitution. Okay, so I'm going to start, and if you want to take my lead and start it this way and then pause it and see if you can finish it, do that. But the more you can do by yourself, the better. So what draws my eye is that if I could just multiply this bottom equation by -1, right? Then I'd be able to cancel out my y's right away. So that's what I'm going to do. I'm going to take the second equation, 5z equals 180 cents. And then I'm going to change the signs in the second one by multiplying everything by -1, making sure I get both sides. And that's going to get rid of my y's for me. So I'm going to have -x plus z equals, and this is why you definitely want a calculator here. There's so many little things that could go wrong. Be cautious and boy, focus on attention to detail and precision. So when you do $100.80 minus $99.20, what are you going to get? $1.60. Okay, so there is an equation in two variables. Now what I'll need to do is take two other equations, okay, and not the third one, and eliminate y. We've already started by eliminating y, so we want to eliminate y in another one. So I'm going to take these two now. I'm going to take these top two, okay? So the easiest thing for me to do is if I don't want to do something complicated, if I multiplied this top one by 12 and this bottom one by 10, can you see how they'd both be 120? Right? But remember, 120 doesn't cancel out. One of them has to be negative. So if what I'm going to do is I'm going to multiply the top by 12 and the bottom by -10, okay? And so that I can change the signs on the bottom one. And here's what I would get, right? 12 times this top equation would give me, and don't spectate, right? Stay ahead of me, then watch. Or you just, there's no way around it besides doing the work by yourself. And you can do it. See, just surprise yourself right now. So you'd get 72x plus 120y plus 96z, and 12 times $97.60 should get you $1,171.20. On the bottom, we'd have -90x, -120y, -50z, and $100.80 times -10 should give you -$1,008. All right? So again, our y's will cancel. 72 minus 90 should give you -18x. I know you're staying a step ahead of me. Hopefully you got 46z. And when you subtracted these guys, hopefully you got $163.20. Okay. So now you've got another equation in two variables here. Okay, so we've got two of them. We've got just x and y left. So what we'll need to do is stack these up, and hopefully you can tell all we would have to do is multiply this top one by, well, let's see now. We're going to need to change the signs, aren't we? Can you tell that? Because we need one of these to be -18 and one to be +18. So I'm going to multiply this top by -18, okay? And that is going to change this first term to, I'll bring it over here, 18x and -18z equals, Negative 18 times $1.60 should give you negative $28.80. Okay. Now I'm going to stack that up with this one here. Okay, so I just fixed this one, and I'm going to stack it up with this one. So I had negative 18x plus 46z equals $163.20. So x's are gone. Negative 18 and 46 should give you 28z. And then negative $28.80 plus $163.20 should give you $134.40. And when you divide both sides by 28, how lucky do we get? $4.80. Okay, so what we have figured out, let's see here. We'll do small, medium, and large, okay? And we just figured out Z, which is our large, right? So we figured out the larges are $4.80. And now we can take it and figure out what the other ones are. So, why don't we just take these two here that I made here in white, and we will plug in 480 for Z. Boy, I'm getting tight on space here. So let's see here. So I would have 9x plus 12y plus 5 times 480 equals 180. Okay? And then I'd have negative 10x minus 12y. The reason I'm choosing these two is because they're already set up for y to cancel out, and it'll be easy for me to solve for x this way. 12y minus 4 times z, which is 480, equals negative 99.20. Okay. So, let's see. Maybe we want to clean those up a little bit. So I'd have 9x plus 12y. If I add those up, or multiply those rather, this times this is 24. Okay, so if I minus 24 from both sides, $100.80 minus 24. You show all your steps so you know what's going on. Should give you $76.80. And then I'd have negative 10x minus 12y. 4 times $4.80 is 19.20. So I have negative 19.20. So if I add that to both sides, negative $99.20 plus 19.20 should give you negative $80. So if you cancel out your y's, you'll get negative x equals $76.80 minus 80 will give you negative 3.2. So x will equal $3.20. So we've got the second one. The smalls are $3.20. All right, now we just got to get the y's. Well, once we've got the x's and the z's, we can pick any equation we want to plug them into and figure out what y is. So if we just use, let's say our very first equation, right? Our very first one, 6x plus 10y and all that. So 6 times 320 plus 10y plus 8 times 480 needs to equal 97.60. So we get 1920 here plus 10y, and 8 times $4.80 is $38.40. equals 9760. So if you were to combine these two, 1920 and 3840, hopefully you're getting $57.60. Go ahead and minus that from the right side, and ultimately you're a couple steps ahead of me. Hopefully you got 10y equals a nice even $40. That's sweet. So y equals 4 when you divide. So the mediums are $4. So small is $3.20, medium is $4, and large is $4.80. Excellent, excellent work. Now, don't turn this off yet. I need to tell you something. Okay, so there are a couple of resources here for you. If you're looking at today's date on our class page, first of all, you see these Khan Academy support videos here. If you click that, there are videos to help you. This particular concept with equations in 3 variables is tricky. So if you scroll down, you'll see activity 5 videos, activity 6. We're on activity 10.6, right? So if you scroll down to activity 10, you'll see when we get to, so here's systems by substitution and all that. And then you'll get down here where you've got, here we go, solving systems of 3 equations in 3 variables. These are 1, 2, 3, 4, 5 really excellent videos that'll talk you through a little bit more and a little bit more and a little bit more if you truly want to understand them, which you need to. Okay, so those are great resources. Then also, once you feel like you get that pretty strongly, then you'll see also on today's date there is an opportunity for you to try some extra ones. So here's a worksheet over here where you can solve systems of 3 equations, and there's an answer key. So you could try them on some loose leaf and then check your work at the end and see if you were correct. Okay. So some of them are fractions and stuff. Don't freak out. So there are a couple resources you could use there. Okay, now that's it. Go forth and conquer. Get this. You got it. You can do it. Never, ever, ever, ever quit. Ask me anything you need to.